Envision an immense asteroid hurtling towards Earth while you engage with this video. Can humanity evade a catastrophic event of monumental scale, or are we powerless in the face of celestial forces? In today's exploration, we delve into the enigmatic realms beyond the cosmic horizon, delving into NASA's remarkable encounter with an asteroid and the pioneering DART mission. Greetings, fellow space enthusiasts. In today's episode, we embark on an exhilarating odyssey into the boundless expanse of the cosmos, where the formidable forces of asteroids loom as potential threats to our planet. Join us as we unravel the recent audacious undertaking by NASA, featuring the DART spacecraft on a mission to alter the trajectory of an asteroid. Did the mission unfold according to plan? Prepare to be captivated as we delve into the riveting intricacies of a surprising asteroid collision that has left NASA scientists grappling with unforeseen twists. Secure your seat as we navigate the mysteries beyond the cosmic horizon. For years, engineers and scientists worked tirelessly on the DART mission, crafting a probe with a singular purpose: to deliberately collide with an asteroid. NASA's Double Asteroid Redirection Test targeted the binary asteroid system Dimos and Doros. Dimos, discovered in 1996, presented an opportunity for NASA to test a new planetary defense technique. Beyond the intricate process of assembling the probe, a pivotal chapter unfolded in the mission's narrative. The objective extended far beyond a mere collision with the asteroid. It aimed at a meticulous understanding of the impact intensity. The overarching goal was not just to create a dramatic encounter, but to delicately displace the asteroid, orchestrating a shift that would redirect it into a safe orbit. This phase of the mission unveils the paramount importance of intricate precision in the realm of planetary defense strategies. The core challenge lay not only in the assembly of the probe, but in orchestrating a collision that would serve as a calculated nudge, altering the celestial body's course without inducing chaos. The intricacy of this precision is comparable to a celestial ballet, where every move must be finely tuned to achieve the desired outcome. The overarching strategy involved displacing the asteroid with utmost accuracy, aiming for a redirection that veers it away from any potential collision course with Earth. This delicate approach stands in stark contrast to brute force methods and underscores the mission's commitment to preserving the celestial equilibrium. It is an intricate dance with the cosmos, requiring a nuanced understanding of celestial mechanics and the ability to implement calculated maneuvers with surgical precision. The exploration of these challenges brings to light the crucial need for precision in diverting potential threats. The stakes are high, and the success of the mission hinges on the ability to navigate through the complexities of space with unwavering accuracy. This precision not only safeguards our planet from impending dangers, but also sets a precedent for future endeavors in planetary defense, emphasizing the significance of methodical, well-calibrated approaches over impulsive interventions. While the concept of destroying asteroids might appear as a direct and decisive solution, the intricacies involved in detonating these cosmic bodies unveil a myriad of dangers that demand careful consideration. The inherent risks associated with asteroid destruction go beyond the initial explosion, with fragmentation emerging as a critical concern. The aftermath of detonation introduces the peril of unpredictable trajectories for the shattered asteroid fragments. These fragments, now liberated from the original celestial body, become celestial projectiles hurtling through space with unpredictable paths. Each fragment carries the potential to pose renewed threats to Earth, as their trajectories become difficult to forecast and control. To comprehend the imperative of a more nuanced approach, we must recognize the delicate balance required in preventing catastrophic chain reactions. Redirecting or towing asteroids emerges as a strategically sound alternative, emphasizing precision and finesse over brute force. This approach involves altering the asteroid's trajectory subtly, steering it away from collision courses with Earth, and mitigating the potential dangers it poses. The significance of this nuanced strategy lies in its ability to avert the creation of a multitude of smaller, unpredictable fragments that could become hazardous space debris. By employing precision-based techniques, we not only mitigate immediate threats, but also ensure that the solution doesn't inadvertently generate new challenges for our planet. The understanding the complexities involved in asteroid defense underscores the need for a thoughtful, strategic approach. Rather than opting for destructive measures, the focus shifts towards methods that allow us to delicately manipulate the celestial bodies, redirecting their paths and safeguarding our planet from the unforeseen consequences that could arise from hasty actions. As we navigate the realms of space, the call for a sophisticated and nuanced approach becomes ever more critical in preserving the delicate equilibrium of our cosmic environment. Contemplating the potential devastation, we draw parallels to the fate the Chicxulub asteroid unleashed upon the dinosaurs millions of years ago. The sheer magnitude of the impact would echo through time, leaving us to grapple with the urgency of developing and implementing effective asteroid defense strategies. In this sobering exploration, we confront the reality that a major asteroid collision could unleash a cataclysmic chain of events, reshaping the very fabric of our existence. The echoes of history serve as a stark reminder of the need for vigilant preparedness and proactive measures to safeguard our planet from the looming threat of celestial impacts. As we navigate the cosmos, the lessons from the past become guideposts for a future where humanity stands resilient in the face of potential cosmic challenges. In the wake of months of eager anticipation, the DART mission reached its crescendo with a collision that surpassed all expectations. NASA's preliminary findings revealed an unprecedented success, a triumph in reshaping Doro's orbit that not only defied projections but also marked a groundbreaking moment in our ongoing pursuit of understanding and mitigating potential cosmic threats. The DART mission is not just a victory for NASA and its international partners. It is a testament to human ingenuity, determination, and collaborative efforts. As we celebrate this monumental achievement, we look forward to a future where advancements in space exploration and planetary defense continue to shield Earth from potential cosmic threats. Let this success be a reminder that armed with knowledge and innovation, we can actively shape our destiny in the vast expanse of the universe. Thank you for joining us on this thrilling journey, and stay tuned for more groundbreaking discoveries in the realm of space exploration.